So we are starting with exercise 18D of limits. Okay, exercise 18D. The entire exercise is based on rationalization except one or two problems. So the meaning of rationalization is taking conjugates. Okay, so when do we take conjugates? That we need to understand, right? So whenever it is root plus or minus root in numerator or denominator, or both, or if it is root plus or minus some value in the numerator or denominator, or both, or some value plus or minus root in the numerator or denominator, or both. Okay, so these three things should be there in numerator or denominator, or both. In that particular case, we do rationalization, we take conjugates. So let us go to question number 1 of exercise 18D. Question number 1: limit x approaching 0 root 1 plus x minus 1 upon x. So it is root minus value. In the numerator, we are having root minus value. Okay. Now, obviously, we cannot put the value of x as 0 right at the beginning of the problem, because if we put x equal to 0 over here, anything upon 0 will be not defined. So instead, we take conjugates. So the conjugate of root 1 plus x minus 1 is root 1 plus x plus 1. So x into root 1 plus x plus 1. So this equals limit x equal to 0. Okay, so this will be a minus b into a plus b. So guys, a minus b into a plus b is a square minus b square upon x root of 1 plus x plus 1. I hope you are copying this. Okay. So the root of 1 plus x the whole square is 1 plus x. The root of 1 plus x the whole square is 1 plus x. And root of 1 is root of 1 square is 1. So what we have to do over here is, in the next step, limit x approaching 0 1 plus x minus 1 x into root of 1 plus x plus 1, right? So what I have done is I have squared this. The root and square goes here, 1 square is 1. Fine. So that I have simplified. Now this 1 and 1 will get cancelled. So we are left with x in the numerator, x upon root of 1 plus x plus 1. This x and this x will get cancelled. Okay. Now we are left with 1 in the numerator. Now can we put the value of x as 0 in the denominator? Yes or no? You can put your answers or suggestions in the chat box. You can put your answers or suggestions in the chat box. Yes, because if we put x as 1, x as 0, the entire denominator won't be 0. So this will be 1 upon root of 1 plus 0 plus 1. Okay, so root of 1 plus 1, and this is half. Take the positive root only. Don't take the negative root in this particular chapter. Fine. When we are solving such type of problems. Yes. Have you understood this problem, everyone? Okay. Yeah. So let us go to the second problem. Question number 2. There are two ways to solve this particular problem. You can also take, one second, let me just write this. x is approaching a. Okay. Now can we put the value of x as a in the denominator? The answer is no, because a minus a is 0 in the denominator. So you can take root x as x raised to half, a as a raised to half, and you can apply that formula, limit x approaching towards a, x raised to n minus a raised to n upon x minus a. But then since we are having root minus root in the numerator, we can also take conjugate. So I'll show you the conjugate method over here. Okay. This is one of the methods, because it is root plus root minus root in the numerator. Okay. Limit x approaching a, root x the whole square minus root a the whole square, x minus a, root x plus root a. Okay. So this equals limit x approaching towards a, x minus a upon root of x the whole square is x, root of a the whole square is a. So x minus a upon x minus a into root of x plus root of a. Now we'll cancel these terms. Now you guys tell me, can I put the value of x as a in the denominator? Yes or no? Can we put the value of x as a? Yes. Now we can put the value of x as a. So this is root a plus root a. That is 1 upon 2 root a. Right? So the thing is, you can take conjugates whenever it is root plus root, root minus root, root plus some value minus root. Okay? In the numerator or denominator or both. So you have to take conjugates at that particular point of time. Okay. So 3, 4, and 5, I leave it up to you. Okay. Third problem, 3 minus root of 5 plus x, take the conjugate of it in the numerator and denominator. Just multiply with the conjugates. Fourth problem, also take the conjugate of the numerator, multiply it with the numerator and denominator. Fifth problem, we have to take the conjugate of what? The numerator or the denominator? Fifth problem. Okay, so I'll just help you with the fifth problem so that there is no confusion. Limit x approaching towards a, x upon root 1 plus x minus 1. Now guys listen, root minus some value is there in the denominator, root minus some value. So that's the basic criteria for conjugates in this particular chapter, root minus some value. So take the conjugate of it and multiply it with the, multiply and divide with the numerator and denominator. Rationalization. Limit x approaching 0, x into root of 1 plus x plus 1. Down it will be a minus b, a plus b. So a square minus b square. Okay. Limit x approaching towards 0, x into root x 1 plus x plus 1. Put all brackets and everything very clearly. Okay. So this will be 1 plus x minus 1. Now guys, see, this x and this x is getting cancelled, and in the next step 1 and 1 got cancelled, sorry, and x will also get cancelled in the subsequent step. So two steps I have done at once. Have you understood this, guys? Or you want to write me to write some more steps over here? Any confusions, you can just put it over the chat box. Any feedback? Waiting for your reply. Yeah. Now can you tell me, guys, in the denominator, which term is there now? Everything got cancelled. Which term is there now? After 1 1 got cancelled, x and x is also getting cancelled. So which term is there in the denominator? Tell me. Denominator 1 is left. X got cancelled. See, I'll just write this once again. Next step, limit x approaching towards 0, x root 1 plus x plus 1. Put all the brackets and all. Now this x got cancelled. Now what is left in the denominator? Come on, tell me. What is left in the denominator? The term which is left in the denominator is 1. So can I put x as 0 now at this point of time? Can I put the value of x as 0? Yes, because it will not affect the denominator. Denominator will not be 0. So you can put the value of x as 0 now. Okay? Put the value of x as 0 over here because x is approaching 0. Right? So what is root 1 plus root 1? What is the final answer for this problem? The final answer will be 2. The final answer will be 2. Right? Let us go to the sixth problem. Sixth problem. There is root minus root in the numerator. Limit x approaching towards 0, root 1 plus x minus root 1 minus x upon 2x. Okay. Root minus root in the numerator, take conjugate of the numerator. Okay. So limit x approaching towards 0. Numerator will be a minus b, a plus b. A square minus b square. Okay. This much I have got. Now just tell me, what is the value of the numerator? Yeah, I'll just wait. Don't worry. What is the value of the numerator? Okay. So you have to give respect to that minus sign in between. Just don't randomly, you know, open all the brackets. So it will be 1 plus x within the bracket minus 1 minus x within the bracket in the numerator. Okay. So limit x approaching towards 0, 1 plus x minus 1 minus x. And down it will be 2x square root of 1 plus x plus root of 1 minus x. The square and root got cancelled over here. I have simplified this term by keeping the minus sign in between and not removing the brackets. So root n square is 1. Fine. Guys, you are clear with this slide? Are you clear with this slide? Okay. So you get this. So this will be limit x approaching 0, Okay, open the bracket. Okay, so 1 and 1 is gone. You're left with 2x. So 2x and 2x is also gone. We are left with 1. Okay. So now guys, can you tell me, can we put the value of x as 0 in the denominator? Is it okay now to substitute the value of x in the denominator as 0? Will it affect the entire solution? Okay. So put the value of x as 0 in the denominator now. The entire denominator won't be 0. So what is the final answer if you put the value of x as 0? Please tell me. Are you calculating the final answer? It's 1 upon 2, right? Okay. So guys, you can take question number 8 and 9 for self-study. Okay, both the problems like it has root minus value or root minus root in the numerator. Okay, so you have to take conjugates of the numerator. I'll just give you the question hint for question number 8. The conjugate of the numerator is this. I'm just writing the conjugate term. So you have to multiply and divide with this. Am I correct? Is this correct? Conjugate of the numerator. Okay. Yes or no? Hello. And ninth problem. The conjugate should be taken as this. This is the conjugate of the numerator. So you have to multiply with this term in the numerator as well as denominator. Fine. Okay. Now I will take you to, this was a hint for question number 8 and 9. Simplify by writing all the steps. Don't take any shortcuts so that you don't commit any silly mistakes. Let us go to question number 7. Now question number 7 is not really of this particular category. I'll tell you why, because the simplification is very easy. Limit x approaching towards 1, x square minus 1 plus root of x minus 1 upon square root of x minus 1, x square minus 1. Okay. So you can split this into two parts. You can split this into two parts. Is this mathematically correct? Is this mathematically correct? Yes, it's very much correct. A plus b upon c is a by c plus b by c. Okay. So this is 1, right? Limit x approaching towards 1, 1 plus. Now you can combine this root because there is division. We can combine the root. In division and multiplication, we can combine the roots. Okay. Now, can someone tell me how to simplify this term x square minus 1? How to simplify this? X square minus 1 within the root, which is in the denominator. The orange colored term. Yes, correct. It is a square minus b square. That is a plus b, a minus b. So it will be x plus 1, x minus 1. Fine. So limit x approaching towards 1, 1 plus root of x minus 1 upon x plus 1 x minus 1. Guys, do you agree with me? I'll show you the previous slide. See? So this term I have written as x plus 1, x minus 1. So now this will get cancelled. We are left with 1 in the numerator. Okay. So this will be limit x approaching towards 1, 1 plus root of 1 upon x plus 1. Okay. Now you can put the value of x as 1 because it will not affect the denominator. Okay. Fine. So look at the calculations. Okay. This is supposed to be the final answer. You can also take LCM root 2 plus 1 upon root 2. Fine. Yes, I'll go to the previous slide. See, first step is split. Second step is to combine the root. We have the liberty of combining the root because it's division. Because it's division. Otherwise, we couldn't have combined that. Okay. And then the simplification. So this problem did not really have x, root minus root conjugate, that kind of a thing. Okay. I'll give you one extra problem. Before that, can you tell me, have you understood this? Any feedback, everyone? Yeah, one extra problem I will give you, then that will be the end of it. So the question is, limit x approaching towards 2, okay, root of 2 plus x minus root of 6 minus x upon root x minus root. Okay. Now guys, as per the rules, it is root minus root in both numerator as well as denominator. So we have to take conjugates of both. Okay, don't take conjugate of any one term. You have to take conjugate of both the terms. So see how I'm writing. So first we'll take the conjugate of the denominator, multiply and divide with the conjugate of the denominator. Now we'll take the conjugate of the numerator. Is first step clear for everyone? Yes or no? Now I will combine this term with this term, the blue colored terms and the green colored terms. For the blue colored terms, I'll apply a square minus b square. So this is a minus b into a plus b. So that is a square minus b square upon the green colored terms. a square minus b square. But then this term, the yellow colored terms, has nothing to do with the rest of the terms. So that will be written separate. It has nothing to do with the remaining terms. But then we cannot just ignore these terms. Guys, you understood? I have grouped the blue colored terms. Those are a square, a minus b into a plus b, that is a square minus b square. The green colored terms, a minus b into a plus b is a square minus b square. And the remaining terms, which are yellow colored terms, it has nothing to do with the rest of the terms. So they are written separate. Okay. Now simplify the box bracket. Simplify the box bracket. I hope everybody is understanding this. Okay. So limit x approaching towards 2. Look at the numerator, this part. 2 plus x minus 6 minus x. 2 plus x minus 6 minus x. And down, it is going to be simple x minus 2. X minus 2. Okay. Now these two terms will be as it is, root x plus root 2 upon root of 2 plus x plus root of 6 minus x. Root of 2 plus x plus root of 6 minus x. Open the brackets in the numerator box bracket. 2 plus x minus 6 plus x upon x minus 2, root of x plus root of 2, root of 2 plus x, root of 6 minus x. Limit x approaching to x plus x is 2x minus 4. 2 minus 6 is minus 4. X minus 2. Root x plus root 2. Root of 2 plus x plus root of 6 minus x. Okay. Now here you are supposed to take 2 common. If you take 2 common over here in the orange colored term, what will be written within the round bracket? So if you take 2 common, what will be the term that is left? That term will be x minus 2, right? So that x minus 2, and down there is one more x minus 2. You can cancel that. And after cancellation, you check whether you can put the value of x as 2 in the denominator. If yes, then you can put it. The denominator entirely should not convert to 0. See guys, x minus 2 is a problem creator. Because if you put 2 over here, 2 minus 2 is 0. So once this x minus 2 term is getting cancelled, that means half of the problem is solved. Okay. So limit x approaching towards 2, 2 into x minus 2 upon x minus 2. Okay. And the remaining terms, root x plus root 2 upon root of 2 plus x plus root of 6 minus. Okay. So cancel these terms. limit of a constant is constant, then you can put the value of x as 2. Because if you put the value of x as 2, the denominator entirely does not turn out to be 0. So root 2 plus root 2 is 2 root 2, and down it will be root 4 plus root 4, right? Take the positive roots. So this will be 4 root 2. 2 into 2 root 2 is 4 root 2 upon 2 root 4. Or simply you can just write it as root 4 is 2, 2 plus 2 is 4. Okay? Root 4 is 2, root 4 is 2, 2 plus 2 is 4. So 4 and 4 is getting cancelled. The answer will be root 2. The answer will be root 2. This completes today's session. Okay?